Alright, section 8.8, we're going to talk about improper integrals. And improper integrals are integrals which involve infinity, in essence. There are a couple different types. The first type we're going to talk about relate to these two graphs here. So as we look at these two graphs, we have y equals 1 over x and y equals 1 over x squared. And these regions are not bounded on the right. So they both have a horizontal asymptote at y equals 0. This graph never actually touches the x-axis, right? This graph never actually touches the x-axis, right? But the area between the curve and the x-axis may still converge to a finite value. All right, so the area that we're going to look at, we're going to integrate from x equals 1. So we're looking at this area, and here we're looking at this area here. Right, so we're going to analyze those two unbounded regions. All right, so let's look at the one on the left first. So we can look at 1 over x. I want to integrate from 1 to infinity. So I want to integrate from x equals 1 all the way to infinity. Right, and the way we're going to do that is we're going to replace this infinity with some variable. I've used b here. There's nothing particularly necessary about making it a b. You can make it any variable you want. So I replace the infinity with a b. So I'm taking the definite integral from 1 to b of 1 over x dx. And then I'm going to apply the limit as b approaches infinity. All right, so I'm going to do this definite integral first. So the antiderivative of 1 over x is ln of x. And I'm going to evaluate that from 1 to b. So then we substitute b and 1, so ln of b minus ln of 1. Then I'm going to take the limit of this as b approaches infinity. And as I do that, this value is going to approach infinity. All right, so it turns out that the area from 1 to infinity underneath 1 over x is not bounded. All right, so the area continues to grow as we move to the right. We keep adding area on out to infinity. If we look at the 1 over x squared, I use the same process. I change the infinity to a b. So I'm going to evaluate this definite integral, and I'm going to take the limit as b approaches infinity. So the antiderivative of 1 over x is negative 1 over x. I'm going to evaluate that from b to 1. So I have negative 1 over b minus negative 1 over 1, which becomes plus 1. So I have negative 1 over b plus 1. The limit of that as b approaches infinity. As b approaches infinity, this term will approach 0. So the overall limit is 1. So what that tells us is that that is a finite area. This area converges to 1 as we integrate from x equals 1 to infinity. All right, these problems, we call these infinite integration limits. So either the lower limit or the upper limit is infinity. This is one type of improper integral where we have an infinite integration limit.